Welcome to the first video in the module on Simio's search step. The objective of the module is of course to learn how to implement and use the search step, which is a common and important step in Simio. So whenever we want to search a collection of objects, we use the search step. Let's have a look at the three models that implement the search step that we're going to cover in this module. So here's the first model. In this model, whenever I hit the remove B button, type B entities are removed and transferred to another location in our model. So as you can see, whenever I hit this button, the red entities are transferred from the input buffer of the first server to the second server. And here is the process that does this for us. So we have the search step right here. The second model that I would like to show you is kind of similar, but this time we have a standalone waiting area and we have two buttons to pull A entities and transfer them to process A server, and another button to pull B entities from the waiting area and transfer them to the process B server. Again, this model is implemented using search steps. Finally, the third model is a model where we have a waiting area, but this time we only want to pull and do the transfer up to a limit. So each entity in the model has a size value associated with it, and whenever a type B entity is about to leave the system, I only pull type A entities such that the sum of their size values is limited by the size of the type B entity that is about to leave the system. So in this example, the sum of the size values for my type A entities in the waiting area is 14. My limit is 15, so I transfer all of them to my process station. And again, if I run in the fast forward mode, the second time it happens, my limit is 40. The sum of these values is less than 40. So again, all of them will be transferred. In the third case, my limit is 15. The sum is greater than 15. So only some of them will be transferred. And again, this model is also implemented using a search step. However, in order to fully understand these models, there are a number of important concepts that we need to understand. So the important topics that we cover in this module are as follows. So tokens and entities, user-defined events, buttons, and queue states are discussed in the first video. Stations and detached queues are covered in the second video. User-defined tokens are covered in the third video of the module. So before we talk about the details of the search step, how it works and actually implementing it in our model, if I run the model, what happens is whenever I hit this button right here, I transfer type B entities from my queue to my second server. So for example, right now if I hit the button, you can see that all of the red entities that are in the queue are transferred. If I hit it again, you can see that I only pull the red entities that are of type B out of my queue and transfer them to my second server. So this is done by a process. So essentially whenever I hit this button, I run this process. And in this process, I have a search step and a transfer step. The search step is used to find realizations of entity instance B, and then I transfer the entities that I found using the transfer step to my input at server 2. So let's take a closer look at the search step. So essentially the search step is used to search a collection of objects. So here is my process in my first model with the search step and the transfer step. And let's have a look at different properties of the search step. So here in this figure you can see all of the properties associated with a search step. So the first property is the collection type, where you specify what is the pool of the objects that you're performing a search on. So you can see we have different options here. We can search in a pool or population of entities. We can search in queues. We can also do our search on rows of a table rows, or we can perform search on different lists, such as an object list or a node list or a transporter list, and so on. So in the case of our model, we are interested in the contents or the entities that are in the input buffer of our server 1. So that's what we have for the queueState name property. For the search type property, we have several options: forward, backward, minimize expression, and maximize expression. So the search type property essentially tells Simio in which order we would like to process the entities that we find. And the forward option that we use in the current model is essentially a first in, first out rule. So we process the first entity of type B in the queue, and then the second B entity, and then the third, and so on. The match condition, on the other hand, is an optional property that is used to filter the search. So we have both type A's and type B's in our queue, but we're only interested in the objects that are of type B. So from all of the candidate objects that are in our queue, we only want to do additional process on type B entities. So only the entities that meet this criterion will be selected. The search expression, on the other hand, is in fact the expression that will be evaluated for each entity that is found by our search step. So if in our search type we choose minimize expression or maximize expression, we specify the expression that we would like to evaluate in the search expression property. And finally, we have the limit property that determines the maximum number of objects to find by the search step. And in this case, since we don't know ahead of time how many entities of type B we're going to have in our queue, when we hit the button, we set the limit to infinity. Now that we know the basic components of a search step, let's go ahead and implement it in our model, but we will come back and talk about some of these properties, such as the queueState or the match condition expression, later in the video. So we're going to start with a half-built model where we have the basic structure of the model in place. So I have my source objects, my server objects, my sinks, I have my two model entity instances, and I've already changed their symbol. So when I run this model, nothing special happens. Entities arrive, wait in the queue, get processed, and leave the system. And as you can see, I have no processes defined. So let's go ahead and define our process. So I'm going to click on Create Process, and in this process I'm going to have a search step and a transfer step. So here is my search step, and then the entities that I find are going to be transferred to input at server 2. So we've already talked about our search step and its properties. So we know that we're going to do a search on a queue and specifically the contents of server 1 input buffer queue. So I have server 1 input buffer contents, as the expression for my queue state name. I'm going to do a forward search, so I just pick the entities in the order that are in the queue, and my matching condition is essentially from the candidate objects that I find, or the candidate objects that are in the queue. I would like to select those objects that are of type B. So is B is the expression that I would like to evaluate. I need to change this to candidate. So candidate.object is B. And again, we'll talk about this expression in more detail later in the video. I'm going to leave the search expression to 0, and my limit will be infinity. So I'm going to find model entity realizations that are of type B, and I want to transfer them from their current station to a node, and the node that I would like to transfer them to is input at server 2. So now I can go back to my model and run the model, but again, nothing happens. Entities are waiting in this queue, they're not transferred, and the reason is I'm never calling this process that I just defined. This process is never run. So when I click on its properties, you can see that the triggering event for this process that results in the execution of this process is empty. There is no triggering event defined for the process. That's why nothing happens in my model. So let's go back to the slides and talk about events a little bit. So we know an event is an instantaneous occurrence that affects the state of our system. And we all know how an event-oriented simulation software works. So we have events that are scheduled to be processed at time now, and we have some events that are scheduled to be processed in the future, and we move forward in time, and we sequentially process these events. And these events may result in the scheduling of some other events in the future. For example, let's say when an entity enters our server 1, that means the input at server 1 that entered event. Let's say this event results in an execution of an add-on process, and then that add-on process results in scheduling of some other events in the future. So events like the example here are the ones that are scheduled and processed automatically as a result of the way Simio's built-in objects or processes behave. So these are the events that I call automatic events. However, there are alternative ways that users can also create new events. So for example, we can use a timer. The topic of a timer is out of the scope of this video, but suffice to say that we can define a timer from the definitions tab and elements. And let's say this timer goes off for the first time at time 0, and then it goes off every hour. And there is no limit on the number of times that the timer goes off. So we have an event called timer1.event that happens every hour. So this is one way that the users can create new events during the simulation run. The users can also create their own events, which is what we call a user-defined event. So a user-defined event can be executed by either using a fire step in a process. So as you can see here, this fire step in my process executes a user-defined event called event1. User-defined events can also be executed using buttons. But this requires user interaction, meaning that the user needs to actually interact with the model by pressing the button to make the event happen. So this is an example from from the model that we're considering in this video. So whenever we hit the remove B button, the event 1, which is again a user-defined event, happens. So the fire step and buttons can be used with user-defined events. However, like I mentioned, the buttons require actual user interaction with the model. So let's go back to our model and implement the user-defined event and the button based on what we just learned. So the first thing I'm going to do is go to definitions and events, and I would like to create a new event called event 1. So now I can go back to my facility view and go to animation and button and place a new button on my facility view, and I can go ahead and rename my button. I can call it remove B, and I can tell Simio that whenever I hit this button, event 1, the user-defined event that I just created, happens. And then I can go to my processes and tell Simio that this process is executed whenever my event 1 happens. So now I can go back to my model, run the model, and now whenever I hit my remove B button, type B entities are found by my search step and transferred to my server. So now that we have completed our model, I would like to talk about the search step and its different components in more detail. So in order to understand how the search step works, we first need to understand the concept of tokens and entities. So entities are actual objects that are dynamically created and destroyed in the facility window. They have a physical location associated with them, and they can move in and out of other objects, which may trigger events to happen. On the other hand, Simio processes are not run by entities but by tokens. So tokens are created and destroyed in the same process. They have their own properties and states, and they also may reference to an associated object such as an entity or a parent object. So let's talk about this concept of token a little bit. So let's say we have an object and we have an entity that visits this object. Now let's say this visit results in the execution of an add-on process. So when this add-on process starts, a token is created, and this token contains references to both the associated object, which in this case is the model entity that is visiting the object, and the object is going to be the parent object. So this token will then execute the add-on process and will be destroyed at the end of the process. We will talk about tokens, and more specifically user-defined tokens and their states and properties in more detail in the third video of this module. So now that we're familiar with the notion of token and entity, let's talk about how the search process actually works. So in this particular screenshot of my model, I have 8 realizations of type B entity in my queue, and I hit the remove B button. So when I hit the button, what happens is a token is created to execute my process. Now keep in mind that we do not see the tokens run in our simulation models, which is why I have created this little animation to hopefully give you guys more insight about how the process works. But keep in mind that everything I show in this animation happens at 0 simulation time. So this token that is created will execute my process, and it executes my search step. And since I have 8 visiting entities of type B, my search process, my search step, will create 8 tokens, each associated with one of these entities. So the original token will be destroyed in the same process, and it will take the original branch of my search step. Now, since I'm using the forward search type in my step, I will start processing the token associated with the first entity of type B in my queue, and then I will go to the second entity and so on. So the token associated with the first entity of type B will be processed. It goes to the transfer step, and what happens is my first entity will be transferred to my server 2, and then the token will be destroyed, and now my process will run the token associated with the second entity in the queue, and that entity will also be transferred to my server 2, and then the process will be repeated for the rest of the tokens associated with type B realizations that are currently in my queue. So now let's go back to our model, and here I have paused the model in the exact same situation that I just showed on my slides. So if I hit the remove button here, and since I'm using the forward search type in my search step, if I hit the step button, I will first transfer B58, and then B60, and then B61, and so on. So let's do it. I'm going to hit step, and as you can see, I have B58, B60, and the next one will be B61. As you can see, B61 is the third one that I process. And also note that this happens at 0 simulation time. So I'm at 12:07:38. If I continue hitting the step, transferring my B entities to my queue, but all of this happens at 0 simulation time. So I'm still at 12:07:38. And finally, as promised, I'm going to talk about queue states and candidates in more detail. So in our model, we are searching in a queue, and for the collection type property, we chose queue state. So a queue state is essentially a list of objects or tokens. So in this particular model, we're looking at the contents of the input buffer of server 1. So this is our queue state that holds the list of objects or entities that are in the input buffer of our server. Now let's have a look at the expression for the match condition. So the expression we have is candidate.object.is.b. So let's look at its different components here. So the candidate part essentially tells us that we're referring to an object that is not the token's associated object. Now remember that when we hit the button, a token is created that executes our search step. But this token is a general token, and it's not associated with our entities that are in the queue. Since we're evaluating an expression that is related to the entities that are in the queue, we need to start our expression with the keyword candidate. The second component determines the candidate type or class, and in this case, our candidates are objects. They are model entity objects. And finally, the last component is the expression that we evaluate. So is.b is either 0 if the entity is type A, or it equals to 1 if the entity is type B. Alternatively, we could have used candidate.modelEntity.isB, and in this case, again, the model will perfectly work. However, we're just further specifying the class or type of our candidate. So instead of just the general object class, we're telling Simio that the candidates in our queue are of type model entity. So in conclusion, in this video, we saw an implementation of the search step in a simulation model where we have a button, and whenever we hit the button, we transfer a certain type of entity to another location in our model. So the related topics that we covered in this video were events, tokens, and entities, and the details of the search process. And also we talked about some of the expressions that we have for the search process related to queue states, and also the match condition and what the candidate component actually means.